Your computer has a CPU. You probably know that. But there are at least 9 other types of processing units inside modern devices. Some handle graphics, some handle sound, and some handle things you didn't even know needed their own chip. In this video, I'll explain every single one. What each one does, how it works, and whether it actually matters to you. CPU. CPU stands for Central Processing Unit. It's the main brain of your computer. Every instruction your system follows, opening an app, loading a web page, even just saving a file, starts at the CPU. Think of it like the head chef in a kitchen. It doesn't cook every dish itself, but it reads every order, decides what gets done first, and keeps everything moving on time. Modern CPUs have multiple cores. Each core can handle its own task. A typical desktop CPU today has anywhere from 4 to 24 cores. But here's the thing. Most everyday tasks, like browsing the web, watching YouTube, or writing documents, only use 1 or 2 cores at a time. So having 24 cores doesn't automatically make your computer feel twice as fast for normal stuff. That is why for most people, a mid-range CPU with 6 to 8 cores is more than enough. You only really need high core counts if you do video editing, 3D rendering, or run heavy workloads that can actually spread work across many cores at once. GPU. If the CPU is the head chef, the GPU is a massive army of line cooks. GPU stands for Graphics Processing Unit, and it works very differently from the CPU. A CPU has a few powerful cores that handle complex tasks one at a time. A GPU has thousands of smaller, simpler cores that all work together at once. That's what makes GPUs so good at rendering graphics, because drawing millions of pixels on your screen is basically the same simple math, repeated millions of times every single frame. But GPUs aren't just for gaming anymore. Video editing and 3D modeling rely heavily on it. Machine learning does too, and so does cryptocurrency mining. The trade-off is power consumption. A high-end gaming GPU can pull over 300 watts by itself. That's more than some entire laptops use. For most gamers and creators, the GPU is actually the most important component in the whole system. Even more important than the CPU, if you have to choose where to spend your money, this is usually where it should go. NPU. You have probably been using an NPU without even realizing it. NPU stands for Neural Processing Unit, and it's designed specifically for AI and machine learning tasks. When you use Face ID on your phone, when your laptop transcribes your voice in real time, when a video call blurs your background automatically, that's the NPU doing the work. A CPU or GPU can technically handle those same tasks, but they use more power and more resources doing it. The NPU is purpose-built for the type of math that AI needs, like matrix multiplication and pattern recognition. It does those things faster and uses much less battery. Intel, AMD, and Qualcomm now put NPUs in their latest laptop processors. Microsoft even made an NPU a requirement for its Copilot Plus PC program. But honestly, most people won't notice a difference yet. The software hasn't really caught up. Most apps still don't take advantage of the NPU at all. So right now, it's more of a future investment than something you will feel today. DPU. In a data center with thousands of servers, someone has to manage all the network traffic and run security checks. Encryption, routing data to the right storage, all of that needs handling too. For years, the CPU handled all of that, on top of running the actual applications. That created a bottleneck. DPU stands for Data Processing Unit, and it was created to take over those background jobs. Networking, firewall duties, storage management. The DPU handles all of that, so the CPU can focus on what it's actually supposed to do, running your applications. Nvidia's Bluefield and AMD's Pensando are two well-known DPU product lines. But here's the reality. If you are a regular PC user, you won't ever need a DPU, and you won't even see one. These chips live in servers and enterprise hardware. They are completely invisible to consumers. But for cloud companies like AWS and Google, DPUs let them run their servers more efficiently and serve more users with the same hardware. So they are a big deal, just not for you and me. DSP. Every time you make a phone call and the other person sounds clear despite background noise, a DSP is doing the heavy lifting. DSP stands for Digital Signal Processor, and it's built to process signals, audio, radio, sensor data, in real time, continuously. What makes it different from a CPU? Focus. A CPU is a generalist. It can do anything, but not everything efficiently. A DSP is built for one specific type of math, signal processing, and it does that math over and over again, extremely fast, with very low power consumption. That's why DSPs show up everywhere. Smartphones, hearing aids, car stereos, wireless routers, even some smart speakers. They handle noise cancellation and echo removal, also audio equalization, compression, stuff like that. The trade-off is flexibility. A DSP can't run general software. It can't browse the web or open an app. It just processes signals. But it does that one job so well that almost every electronic device you own has at least one DSP inside. You just never think about it. VPU. Picture a warehouse robot that needs to navigate aisles and avoid obstacles while reading barcodes, all in real time, all day long. That's exactly the kind of job a VPU was designed for. VPU stands for Vision Processing Unit, and it's built specifically for computer vision, helping machines understand what a camera sees. Intel's Movidius was one of the most well-known VPU chip lines. These processors handle visual data right on the device itself, without needing to send everything to the cloud. That saves bandwidth and makes response time much faster. You will find VPUs in drones, security camera systems, industrial robots, and some smart home devices. They run object detection and depth sensing. Some also do motion tracking or facial recognition. But VPUs are niche hardware. Most consumer devices now handle vision tasks through the GPU or the NPU instead. Dedicated VPUs mostly show up in commercial and industrial settings where real-time visual processing is critical and every watt of power matters. ISP. Open your phone camera right now and point it at something. The image you see on screen looks bright and sharp, but the raw data coming off the camera sensor looks nothing like that. It's dark and noisy, basically flat. The ISP is what makes the difference. ISP stands for Image Signal Processor, and it turns raw sensor data into the photos and videos you actually see. It handles white balance and exposure correction, noise reduction, HDR blending, autofocus, face detection. All of that happens in a fraction of a second, every single frame. This is why two phones with the exact same camera sensor can produce very different-looking photos. The ISP and the software pipeline behind it often matter more than the sensor hardware itself. Apple, Google, and Samsung all design custom ISPs specifically tuned for their camera systems. The downside is that heavy ISP processing can sometimes over-smooth skin or over-sharpen edges. Colors can end up looking unnatural too, but for most people, the ISP is the reason their phone photos look far better than they have any right to. PPU. Back in 2006, a company called Agea launched something unusual, a dedicated PPU card. PPU stands for Physics Processing Unit, and its entire job was to handle physics calculations in video games. Explosions, cloth movement, water splashing realistically, debris falling and scattering, all processed by a separate chip instead of the CPU. Games that supported it looked significantly more realistic. You could blow up a wall and watch hundreds of pieces scatter across the floor, each one bouncing and rolling independently. It was impressive for its time. Then in 2008, Nvidia bought Agea and moved all physics processing onto the GPU. The dedicated PPU card disappeared almost overnight. Today, physics calculations are handled by either the CPU, the GPU, or a combination of both. There's no separate PPU in any modern system. But the concept lives on. Games keep getting more complex, and physics simulation keeps demanding more power. Some developers are pushing for more GPU-driven physics, so the PPU as a physical card is dead. But the work it was built to do never went away. It just moved to other chips. SPU. Most people spend hours comparing CPUs and GPUs when building a PC. Almost nobody thinks about sound processing, but dedicated audio hardware used to be standard. SPU stands for Sound Processing Unit, and it's a chip designed specifically for handling audio. In the early days of personal computing, sound cards with their own dedicated processors were normal. Creative Labs and their Sound Blaster line were famous for this. The SPU handled 3D audio positioning and reverb. It also did surround sound mixing, jobs that would slow down the CPU if handled in software. But CPUs got faster, a lot faster. Eventually, they could handle audio processing without any noticeable performance hit. Dedicated sound hardware became less common. Today, most motherboards just use an integrated audio codec, a basic chip soldered onto the board. It's good enough for most people. But audiophiles, music producers, and competitive gamers still use external DACs or dedicated sound cards for lower latency and cleaner output. Better spatial audio is another reason. The SPU didn't really die, it just became optional for the average user. IPU. IPU stands for Intelligence Processing Unit, and it's one of the newest entries on this list. A UK-based company called Graphcore designed the IPU specifically for machine learning workloads from the ground up. Here's the key difference. A GPU was originally built to render graphics. It was later adapted for AI training because it happened to be good at parallel math. The IPU skipped that detour entirely. Graphcore built it for AI from day one, using a completely different architecture designed to handle the irregular, scattered data patterns that are common in modern machine learning models. On paper, it sounded great. Graphcore claimed their IPU could outperform GPUs on certain AI tasks, but the real world doesn't run on benchmarks alone. Graphcore struggled commercially and was eventually acquired by SoftBank in 2024. The problem was simple. Nvidia's CUDA software platform had too much momentum. Almost every AI researcher and every major cloud provider had built their entire workflow around Nvidia GPUs. Having faster hardware wasn't enough without the software to match. For now, GPUs remain the dominant choice for AI work. The IPU is a good reminder that winning on specs doesn't always mean winning the market. So those are all the major processing units, from the CPU that everyone knows to the IPU that almost nobody has heard of. Each one was designed to solve a specific problem faster or more efficiently than a general-purpose chip ever could. Some of them, like the GPU and the ISP, are inside every device you own. Others, like the DPU and VPU, live in data centers and factories you won't ever visit. Anyway, I also made some other cool videos too. Don't forget to watch them later. Okay,